Welcome, ladies and gentlemen, to this video lecture. Okay, so we are busy proving this theorem that gives us this expression, or that claims that this expression holds for the error that we are making with our nth Taylor polynomial. So we have completed our base step. Now we will do our induction step. Okay, so our induction step always takes the form of an implication. So what we will do is we will fix any k, and now we have to prove that if our kth statement is true, then our k plus 1th statement is true. So we are saying if ek is equal to this expression, so meaning if this statement is true, then this statement is true. So our so if ek is equal to this expression, then ek plus 1 is equal to that expression. So this is the statement that we want to prove. If this, then that. So since this is an implication, we start with assuming. So assume that ek of x is equal to the integral from a to x of fk plus 1 t over k factorial x minus t to the power k dt. So why are we making this assumption? Because we're trying to prove this implication. So if this statement is true, then that statement is true. So we assume the hypothesis, and now we want to show that this statement is true. So what will we do? We will consider the following expression: a to x of f k plus 2 t over k plus 1 factorial x minus t k plus 1 dt. And if we do integration by parts, which we will leave as an exercise, what do we obtain? We obtain the following. So we get minus f k plus 1 a at a x minus a k plus 1 all over k plus 1 factorial plus, and what we will see is we will obtain ek. Okay. But on the other hand, by definition, we know what ek plus 1 at x is. What is that? That is nothing but f of x minus the k plus 1th Taylor polynomial. But if we think a little bit, this k plus 1th Taylor polynomial, this is the same as the kth Taylor polynomial with one extra term added. So this is the same as pk of x minus, and what is now the utter last term of the k plus 1th polynomial? That is the k plus 1th derivative of f at a k plus 1 factorial x minus a to the power k plus 1. Okay. But what is this? This is just ek at x minus this term over there. And now we see here this expression is the same as that expression. So the only difference here is that the two terms are swapped, but we've got this minus there, minus there. So this term same as that, that term same as that. So these two expressions are actually equal. So therefore, what do we have? We've got ek plus 1 is equal to this, but this is equal to that, but this is equal to this expression over here. So that is a x fk plus 2 t over k plus 1 factorial x minus t to the power k plus 1 dt. Okay, and there we have shown that for all, or now for any fixed k, we have shown that if ek is equal to that, then ek plus 1 is equal to that. So now by induction, what do we have? So by induction, for all natural numbers n, we have an expression for en, which is the integral from a to x f n plus first derivative t over n factorial x minus a to the power n dt. Let me just double check that this is written correctly. Yes. Okay. So here we have now proven by induction that the error for our or the error that we are making at x between our function value f of x and its Taylor polynomial at x, or its the Taylor polynomial for f about a evaluated at x, that error is given by this expression. Okay, and that completes this proof. I will see you in the next one.